So today I'm going to do 16.4, which is on absolute motion of bodies, and the idea is very similar to the pulleys problems I solved earlier. You write x to be the unknown, xa or xb to be the what you are interested in, and then you try to find that as a function of the other lengths, and then you differentiate once or twice to get velocity and acceleration. So I will illustrate this with an example, and that will probably make it easier to understand what I've just said. So this is a simple motivating example. Okay, so OA is a rod, and AB is a spring, and you're given that you're given L. Let me call it L1 actually, L1 and L2. So you're given where the spring is attached to the ground. You're also given the distance L1 of the rod where the spring is attached. So given L1, L2, theta, and let's say that you move the rod upwards with a certain angular velocity, let's call that omega, and angular acceleration alpha. So you're given omega and alpha. So the question is, find x, which is the length of the string, the spring, x dot, which is the rate at which you move the spring up, and x double dot in terms of L1, L2, theta, omega, and alpha. Okay, so we need to find x first in terms of all the things which are given. So can you think of a relation between x and other things, L's and theta? Sine? I was going to use the cosine rule. Have you guys heard of the cosine rule for triangles? Okay, I'm going to review the cosine rule and sine rule a little bit later, but let me just write the cosine rule. So the cosine rule is for a triangle, and it says that if you want to find x squared, which is this, then it's going to be L1 square, the adjacent side, plus L2 square, the other adjacent side, minus 2 times L1 L2 times the cosine of the angle between L1 and L2. So that's going to be cosine of theta. Okay, it's called the cosine rule because there's a cosine in that formula. Yeah.
What is on the left?
This?
Squared?
This is x square. So x is L1 square plus L2 square minus 2L1 L2 cosine of theta. Okay, I'll make it better, easier to understand. Hold on.
Wait, but your x dot, and your x double dot are all great.
Exactly, that's exactly what I was planning to do. Yeah. Okay, is that better?
Beautiful.
Okay.
Artistic.
So if that's x, then so that was one of the things which you asked. Now, can you find x dot? Well, it's as simple as taking the derivative of x. So x dot is, it's going to be the derivative of this thing. So I need to write L1 square plus L2 square minus 2L1 L2 cosine theta, and this is half, so it's going to be half here. So I'm using the formula. If I want to do derivative of x raised to n, it's n times x times n minus 1. So it comes out to be, there's a half, if you like, this is half, and so when you take the derivative of that, it's going to be half first, half minus 1, so that's going to be minus half, so I move that down, and then the derivative of this whole thing, which is derivative of L1 square with respect to time, is 0 plus 0 minus 2L1 L2. Derivative of cosine is minus sine, and then I need to take the derivative of theta with respect to time. That is going to be d theta dt, that's going to be omega. So x dot is, I'll cancel this off, so L1 L2 sine theta omega divided by square root and then to find x double dot, I'll have to take the derivative of x dot, and I would like you to fill in the dots. I'm not going to write it down. I want you to do it yourself. I'll eventually write the answer. I mean, I will write it later on and post it, but I would like you to do it yourself and not just copy me down. So the key idea is, so when you're solving the motion of bodies which are connected the way like this particular problem, what you need to do is you need to write x. X is the unknowns, the things which you're interested in knowing how they move, as a function of the things which you know about. Like in this case, it was theta L, that's about it. And then you want to take the derivative, so differentiate x as needed. And then you're going to use theta dot is omega and theta double dot is alpha. Okay, so we'll see that all the problems we will do in this section boil down to writing the things which are unknown, x, as a function of things which are known, and then taking the derivative of x with respect to time and using the fact that you know what theta dot and theta double dot is. Is that clear? How many of you remember cosine rule? Okay. Okay, I'm going to give you a list of formulas which you should know, and it will help you to solve problems. So this is a review. So if you have a circle, and let's say that so these are two lines which join the center of the circle with the circumference, and if theta is this angle, then x, as shown in the figure, is given by, so let's just call this r, the radius. So what's the relation between x and r and theta? Can you write x as a function of r and theta? What you can do is you can draw a perpendicular like this. This is 90 degrees. So this thing is theta divided by 2. So now you can see that this part is r sine theta divided by 2, right? But there are two of those things. This is one and there's another one. So this is 2r sine theta divided by 2. Yeah, you're saying, can you use x square equals? Yeah, so you could also use this if you like. X, well, you could use the cosine rule.
So we can't use the fact that.
You're saying this thing, Pythagoras Theorem?
Well, it creates a special right triangle, right?
Yeah, I created a special right
triangle. Got x square root of 2. I guess that won't work.
No. You could use the cosine rule, which I'll just talk about. You could use this. You could also use cosine rule to get that same expression. Before that, let me review the Pythagoras theorem. So if this is 5 and this is 12 and you're told to find what a is, then a is simply a square is simply 5 square plus 12 square. Yeah, that's probably very simple. Now, if you are given a triangle, and let's say that you're given this is 30 degrees, let's say this is given to be 2, this is given to be 3, and you are told to find what this angle is and what this side is, x, then you can use these two formulas. So one is the cosine rule, which states that x square is 2 square plus 3 square minus 2 times 3 times cosine of 30 degrees. So this way you are able to compute x based on two adjacent sides and the angle opposite to x. It has to be the angle opposite to x. Can't be any random angle. And then there is something called the sine rule, which goes like this. It says 2 divided by sine alpha, where alpha is the angle opposite to the side which is 2, is equal to 3 times, well, I can call this, let's say, beta. Let's say if you're interested in knowing beta too, then it's 3 divided by sine of beta equals x divided by sine of 30 degrees. So if you look at this formula carefully, it basically takes the side and the angle right opposite that side. So here's something you want to remember. If you want to completely determine a triangle, lengths and angles, then all you need to know is you could know 3 lengths, so you know the sides of the triangle, you can find the angles. If you know 2 sides and an angle, you can still find all the other angles and the sides of the triangle. You need 3 pieces of information to completely determine the sides and angles of a triangle. However, if you're given 3 angles, only 3 angles and not any of the sides, then you will not be able to determine the dimensions of the sides. You'll only be able to determine the ratios of the sides. Okay? if you want to know the triangle completely, you need at least one side, and the other piece can be a side or the angle between the sides. So 3 pieces of information are required, but one of them has to be a side to get the complete information for a triangle. So these are the 2 rules I would say are very important, cosine rule and sine rule. It turns out that you could use the cosine rule, this rule, right here to find an expression between x and theta. So x square is r square plus r square minus 2r times r cosine theta. And if you do the simplification, it'll actually come out to be 2r times sine theta divided by 2. Okay, so you can do it. It's 2r square 1 minus cosine theta. I skipped a few steps. So 1 minus cosine theta is actually 2 sine square theta divided by 2. And now if you take the square root, you'll actually get this expression, right? Okay, so I would recommend that you remember this. Don't memorize it. Just think of it in terms of sides. If you want to know x or any side, you got to look at the square of the adjacent side, sum of the squares, minus 2 times the product of the 2 sides times cosine of the angle opposite. It's just simple as that. Don't memorize it. I don't know if it's in the formula sheet. I believe it's not on the formula sheet, right? But it's not too hard to memorize this. Also the sine rule, it's simply the side divided by the angle opposite the side, and same for the other sides. I would say these 2 rules by far are the most useful ones. In fact, you can actually derive this formula, the Pythagoras Theorem, if you use the cosine rule. So if you put x equals a, then you'll see that you'll get 5 square plus 12 square minus, it'll be cosine of 90, which is 0. So you'll get the Pythagoras theorem from the cosine rule. So cosine rule and sine rule are more important than other ones. You can derive the other equations using those. Okay, so any questions on this? Okay, let's start with problems. Now, did you guys see that I post these things the week before? I actually post these notes without my solution, so that you can then print them out if you want to, and then start solving it in the class. You don't have to sit and draw the figure and write the problem. Okay, so I'll be doing that for the rest of the semester. You feel free to print it and get it to class and solve it on that piece of paper instead of trying to scamper and write this down. Okay, so this problem is as follows. So the crank AB is rotating with constant angular velocity of 4 radians per second. You got to find the angular velocity of the connecting rod CD. So C is this, D is this, at the instant when theta is 30 degrees. Okay, so it seems that you need to find the angular velocity of CD. Okay. Okay, what is the angular velocity of the connecting rod in terms of the variables which are given to you? Can I say that the angular velocity is theta dot? Theta is the angular velocity of, well, theta is the angle made by CD with the vertical. So rate of change of theta is going to give me the angular velocity of CD. So this is something which I need to find. That's an unknown. Okay, so if that is an unknown, I need to find an expression for theta in terms of things which are given to me. Okay, so how do I proceed? So there is theta, which I'm interested in. I know the length, 600 is this length, and that does not change with time, right? As the connecting rod moves, that distance remains the same. This is the distance from A to B. When the connecting rod moves, AB just stays as it is. It's a link. It's not going to change its length. However, this thing here, this angle here, CAB, is going to change with time, right? So what I'm going to do is I'm going to write this as some variable alpha. Okay, and that I do that only because eventually I want to take the derivative of alpha. Okay, if I write it as anything else, I put a value, then it'll give me 0. I don't want that to happen. So that's alpha, that's theta. I know what alpha dot is. It is 4 radians per second. And I want to be able to relate theta with alpha, so that then when I take the derivative of theta, I'll get in terms of alpha dot, and then I'll be able to find what I need, which is theta dot. So how can I relate alpha, theta, and what else is given? 600 and 300. How are they related? Sine rule. Okay, if I take the sine rule, then it's going to be 600 divided by this angle and 300 divided by that angle. But then I'll have to find this angle. Let's call that beta. In fact, if you're confused, you can assume that, well, let's take this as x, and I'm just writing this down so that I can, as I told you, if you know three numbers, then you can completely determine the triangle. So you know 600, you know that one side is 600, other side is 300, and the angle is, one of the angles is 30, which means that you should be able to find x, beta, and alpha just using the cosine rule or the sine rule, or in conjunction with, you can use both of them to find that, whichever is easier. There's no extra information in the sine rule really. The cosine and sine rule, you can use either of them to find the unknowns. So I'm going to just put x, beta, alpha, so that way I've put variables for everything, and then try to see if I can find an expression. Okay, so what can I write? I can write the sine rule, 0.6 divided by sine of beta equals x divided by sine of alpha equals 0.3 divided by, so I converted that from mm to meters, sine of theta. Okay, so I know this is 30 degrees, right? So then I can use these two, I can equate this to that to get sine beta equals 0.6 sine of 30 degrees divided by 0.3, and if you do this math, then it comes out to be, so beta comes out to be 90 degrees. Which is really nice, because once things are 90 degrees, you can use the Pythagoras theorem. So it comes out that this angle here is 90 degrees. So if beta is 90 degrees, what is alpha? 60. Is 60, that's right. It's 60 because the sum of the angles in a triangle is equal to 180 degrees. So if beta is 90 and theta is 30, then that should be 60 for it to be 180 degrees. Okay, so I have alpha 2 now. All I need now is to find an expression for theta in terms of things I care about. Things like alpha, beta, and what else? 600 and 300. So what can I do?
Can't you still use the sine rule
To get x? Okay, I can get x. But then my biggest concern then is if I get x, then I'll have to take, when I take the derivative, I'll have x dot. I don't know what x dot is. I know what alpha dot is, but I don't know what x dot is. So it'll just make, I could work with x dot and find an expression for x dot too, but I think that might be more work. Is there a simpler way? That, worst case, that's the way to go. You should do that. But is there an easier way? Yeah, I'm looking at theta dot. Want to find this.
The x is not fixed, right? It can change because this is cos.
Can you say that again?
The x is not the fixed number because it's moving. This one, the
X is going to change, right? X will change with time. X is not fixed. Cosine of which one? Cosine rule. So if you use cosine rule, 600, you can use that. Let's see, 600, 300, x. But again, there'll be an x. So if you use cosine sine rule, you'll always end up with, not sine rule, but cosine rule, you will have an x in that. You cannot avoid that because in the cosine rule, you always have all the three sides coming in the cosine rule. So here, see if this makes sense. I'm going to redraw this triangle. This is 0.6. This is 90 degrees. This is 0.3. This is 60 degrees. And let me write this as alpha. And this as theta. So this length here is going to be 0.3 cosine alpha, right? And this thing here, this distance, is going to be 0.3 sine of alpha, right? And so I can write tan of theta equals 0.3 sine of alpha divided by this side, right? This side is simply 0.6 minus 0.3 cosine of alpha. Okay, and the reason why I did all this jugglery is because I don't care about x dot. I don't want them to come in the equation because if I get an equation in terms of x, then I'll have to find x dot, and I'm not given x dot. I'm given alpha dot, and I need to find theta dot given theta. So I try to write everything in terms of theta and alpha. Okay, so the number of ways to differentiate this, you could just take the derivative as it is here, but I think it makes it is perhaps simpler to write it like this and then take the derivative. So I move things around, and so I'm now going to take the derivative of this expression. So 0.6 is 0 minus 0.3. The derivative of cosine is sine alpha. It's negative, so it's plus, and then alpha dot times tan of theta plus 0.6 minus 0.3 cosine alpha times the derivative of tan theta, which is secant square theta, times the derivative of theta, which is theta dot, equals 0.3 cosine alpha, because derivative of sine is cosine, times the derivative of alpha, which is alpha dot. So in this equation now, alpha is known, it's 90, theta is known, it's 30, theta dot is unknown, but alpha dot is known. It is given to be -4. It's positive, sorry. Okay, so solving for, so alpha is 60 degrees, sorry, 60, and theta is 30 degrees. So solving alpha dot is, sorry, theta dot is, the answer is 0. So it's instantaneously at rest. This doesn't mean that it's going to be at rest all the time. Okay? Theta dot need not be 0 all the time. It can be changing time. Okay, so a circular cam, where is the cam? I think it's this one. Rotates about a fixed point O with a constant angular velocity omega. You're going to find the velocity v of the follower rod AB as a function of theta. So let's see what's given. You're given omega, this thing. You're given theta, which is this angle. You're also given r, though it's not mentioned there. And then you're going to find v as a function of theta, omega, and r. You are also given, I just saw it, you just also given capital R, which is the radius of the cam. Okay, so if you want to find V, in this case, V is going to be the derivative of a position which is somehow related to velocity, right? So I'm going to try to find what is that which when differentiated will give me V. Okay, what is that in the figure which when differentiated will give me V? So I think that a good candidate for that would be V is actually the motion of point A, it's also the motion of B, so it's actually the motion of this whole thing, AB. So I can take any point on AB. So let's take this point, A, okay? And then find its motion relative to O. I'll call that X. This is just telling me how, this is just setting up the problem so that I can, if I differentiate X, I will get V, right? Because X is the motion of A and the derivative of the motion of A is going to be velocity. So if that's X, all I now need to do, so the key thing is finding X. Once you find X, you got to find a relation between X and things which I know, which is R, small r, capital R, and what else? Theta and omega. So can you think of a relation between X and things I know about? So let me help you. So I'm going to complete the triangle. Okay, now I have a triangle formed by, okay, I think there's another thing which you know, I just saw it again. D is also known.
What is X from where to where? It's from
X is from,
it's from
so it's from the stationary point O all the way to A. So can you find X in terms of things which I know about, the geometry of the various things in this? So I can drop a perpendicular like this, might help me, just like I did in the previous problem. So it's given by this piece and this piece, right? X is this piece plus this piece. So piece 1, as I put in the figure, is what? What's this? It's d cos, somebody said that, d cosine theta, that's right. And what is part 2? What's this? X minus d cosine theta. Yeah, but if I write x minus d cosine theta, then I want it in terms of, I don't want it in terms of x. I want it in terms of other things.
So our capital plus
What's that? So this is what? What's this side? Big R plus small r. Okay, now can I find 2?
so this one commiserate this sine of
Big R plus small r.
No, cosine, yeah. So that will give me, no, you don't know the angle. This is not theta.
but we know the vertical is gonna be the sine of theta. The
Sine of, so you know this.
yes.
Yeah, that's going to be r. That's going to be d sine of, yeah. So what she says is this thing here is d sine of theta. You agree? Everybody else agrees that's d sine theta? So then what is 2 then?
So it's gonna be this square minus this square.
Yeah, so she says that it is r plus r square, sorry, r plus r the whole square minus d sine theta square, the whole thing in square root sign. So what she did was she saw that this thing is r plus r, this height here is d sine theta, so this thing can be found by the Pythagoras theorem, right? So that's it, that is x. Okay, so and you can see that x, in terms of everything we know about, we know theta, d, small r, and capital R. So x dot is this derivative. I won't spend too much time doing that. Please try to do it yourself and check with this answer. Okay, so I just have 4 minutes.